Hello, everyone. Uh, Good day. Science Hype. I don't know where you are located in. I'm in Brazil, so it's good morning here. Uh, just a moment. I will put my phone in focus mode. Okay. Uh, so this talk is about file transfer, as you can see. Uh, so it mixes two things that I like with this art and Python. So let's get started. Okay. And I'm Isaac. Uh, I'm a software engineer. Let's present myself. I born in Brazil, and I'm living here in Brazil, actually, in Fortaleza, which is a city in the northeast of the country. It's well known by the beach and some travelers and forró and a lot of songs here in Brazil. I'm a master's student at Federal University of Ceará in databases field. In my research area is natural language processing. So I'm at the beginning, so I did not had so much experience in this area. It's like a challenge to me, but I'm learning a lot. So, and I'm a researcher at Insight Data Science Lab. It's a lab inside my university. So as part of my master's degree, I had to read a lot of articles and do some research to my paper presentation next year. So this lab is helping me with that. And I'm a software engineer, a consultant at Squadra. It's a consultant company here in Brazil. Besides Python, I have experience with Flutter, with mobile development, and full stack development with .NET and Java. So a little about myself. I really love coffee, so I had a entire space for coffee here, and I visit a lot of coffee shops in Fortaleza. And I love astronomy too. It's something that I like to study, and with the recent advances, we have a lot to study and to observe. And I'm a Star Wars lover too. So let's come to the Jedi side of the Force. Starting, when we talk about art, it's very difficult to define art, because something that is art today was not art yesterday or in the past decade or in the past century. We can provide as example the Van Gogh paintings with in the time that Van Gogh was alive was not so considered art by some people, and today it's a very piece of art. So this concept varies along the time, but we can define using Oxford Dictionary as a variable cultural construction without constant meaning. So this could differ tomorrow, and we can define too as activities linked to manifestations of an aesthetic or communicative nature. So if I want to communicate something about what I'm feeling, or what about my reality, or about my work. I can make a painting or a sculpture or something different and present to other people, and this will be considered art or no, not today. And so we have an example of this picture of Fontaine of Marcel Duchamp, a work of Dadaism school. So the Dadaism school was a rupture with the other schools of art. So the Dadaism made some piece of art very different to what the people was used to see. So this is one example of art. I guess this was not art when they released these works. So another question we can make, just humans can produce art? I can't see you writing, if you're writing something, but you can answer to yourself. So let's proceed. Well, I can't answer if just humans can make art, because I'm not a specialist in art. I'm just a admirer, but I can make some opinions, and I think we can experiment with those things. And this year, this work of Jason Allen's was the first AI generated art to win a prize. So this work is named Teatre d'Opera Spatial, and it won the first place at the Colorado State Fair. And this winning started a new thread about generated art by AI. Style transfer is not something new. I think we have 10 years or 20 years of existence, but in the recent years it got all of us. And this year, with this prize, we got the main attention of some people, and some artists. Some people disagree this is art, and some agree. And we have this discussion until today. And I think this discussion, we have a lot to deserve. So, what is style transfer? How can you define that? We have some system as a service of AI and filters, and something you can put your photo, and some AI will do some work in that photo, and you will look like a piece of art. Or you can, we had this year the viral of Lensa too, that sure uses AI, and it's something that got viral. So we had a lot of technologies like Face App, and I forgot the other technology that I was going to talk, but you just made a Google and do a Google, and you will find a lot of these technologies. So it's something very present at all days. And what if we were possible to apply the style of Van Gogh painting through a photo of a sunset that you took at your phone, or your selfie, or the photo of your cat? You can, yes, you can. It's possible now. So basically, we try to separate what is style and what is content of an image. So we must have two images, one for style. So in this example, I forgot to remove the grids, and I'm sorry for that. But in this example, I used Starry Night of Van Gogh as my style, and I used the sunset picture of a city near to Fortaleza here, and where I was traveling, and I took this photo, and this photo is my content. So what is the style? The style is the color patterns, shade of brush strokes, the technique used, everything that made the painting itself. So the content is something different. Every photo you can imagine. So when you have a style image, we call A, and any image for transfer we call B. We can transfer the style of B by modifying the content. But sorry, we don't modify the content. By modifying the image A, applying this style. So, but we have to preserve the content. So let's move on. And this is possible. We have a lot of we have a different way of doing style transfer now. Since we have GANs networks, but this presentation will focus on convolutional neural networks. But yes, you can do this different without using convolution. But many of algorithms are based on convolutional networks. And we have this work here, 2015, as a great work one of the great works in the field of convolutional networks for style transfer. So it was some of the first works in this area, and I'm sorry, one of the first most read and impact works in this area. Was not, I believe, was not the first one. So how convolutional neural networks works? So convolutional neural networks consist of layers of small computation units that process visual information hierarchically. So what are you talking exactly? We have a image as an input, and the CNN, I will abbreviate to that. The CNN will look to this photo, to this picture, and will apply some filters. I have a picture of filters in the next slides, but this CNN will apply some filters in this matrix. So every image will be transformed in a matrix, because the AIs often see everything as a very number of matrices. So with image will be not different. So the CNN will look at some pieces of my image, and we look for some patterns and some patterns, and we will identify these patterns, and this will happen hierarchically. So we have this convolution layer that will identify something and pass to the author, and we will follow the flow until we have a identifier of this pixel. So as here we have a mouse picture, and all filters will identify this part of the picture with a curve. So we have some filters, and for example, the filters will begin here and we identify that. I don't know if you see in my mouse, but I will keep. So I will identify the first part of the picture until I see this cube here, and when I identify something different, my CNN will apply some math things to this picture. So this is how CNN will understand and will see the world. Everything is matrix. So how is magic flows? Well, there is as I explained before, there's a lot of ways of you do style transfer, and you can use TensorFlow Hub too to you made something to transfer some to you play, and you just transfer something very fast to another picture, and you can use some architecture, and you can use these architectures to do some work for you. So in this experiment we use VTG 19. You can use VTG 16 or HasNet or everything you want. And we have to has two images as an input to our network. So in this example, we have this cat image as a content, and we have this art picture as style. I forgot the name of this art, I'm sorry. I think it's the great tsunami or something like that. I know the Brazilian name, but I don't know the English name of this art. And we will extract the style of this art picture to our target image, and the final result or the final output is the target image. It's called target. So it's the final result of our network. So we transform the images into numerical matrices. As I said, the networks will see matrices and numbers. So they will you have to pass this to matrices, and we have to extract the features or all the information of this image. We have to compute the gram matrices. If you don't know what is gram matrices, you don't have to worry. It's math. You just have to get the height, weight, and I think the depth of your image, and you multiply your matrix by his transpose. So when you have this information, you just have to multiply this matrix by the transpose of this matrix. It's a formula you just have to put in code, and you will do this for each layer in your style image. Before we set the weights for each style layer, and for content. And at the final step, we update the target image and calculate losses. So one way of do that, show me the code. We already selected the images and we already selected the architecture. So this is just the workflow of doing this type transfer. Don't worry if you don't understand that at principle. It's a lot of definitions. Then we try to do this. We try to keep this talk as introductory to that field. So in the 1 to 5 lines, we have a number of steps. In the 4 line, and in the line 3 we set Adam as optimizer. So we will get in a for loop. So we will get target features in the line 8, and we calculate the content loss of in the line 10. So this is just a another math calculation. You have to calculate the square of the difference of the target features in this convolution layer and the content features in this same convolution layer. So in this next step, we will calculate style loss, and so we get the target feature for that layer that we are in the interaction. So as I said, we will get the depth, height, and weight in the line 15. And in the line 17, we will get the gray matrix for this layer. And on 19 to 22, we update the style loss. And in 25, we calculate the total loss with this the style weight, much times style loss plus content weight times content loss. So it's just that, and we move forward to the next step, since we have 2,000 steps to pursue. And I just made in 31 to 35, just made a plot, every 400 steps. We will plot how image is going. If it is not beginning to be a great image, we can stop the execution and update the parameters, or just select new images and move forward. So we have some examples here that I was experimenting. The first image is a meme here in Brazil. It's just a guy trying to fight with a gate. And we have a Bapuru that is...
Hi, Isaac.
Yeah.
Yeah, sorry to interrupt. It seems we've run out of time already. So you can
Okay.
go already.
Okay, I'm just finished. So I have I will not describe the image, sorry, just because of the time, but beginning we get that was a good image. We have